So we know we got the acceleration is 24.319 meters per second squared. Now what does that mean? That means acceleration is to the right. Positive 24.319. So what does that mean? If the block is moving to the left and it's accelerating to the right, it means what? That the block is slowing down, right? That's actually perfect. When should the greatest acceleration be achieved? The greatest acceleration should be achieved when it's most compressed or most stretched, right? In the center, the acceleration should be 0 because momentarily it should reach its highest velocity in the center and it shouldn't be accelerating for a split second, right? Okay, so that makes sense. So now we gotta find what is the potential energy. Potential energy is equal to half kx squared. So we have to do half times 49, and then the x, we have to take the position, negative 0.248, and then you have to square that. Well, since you're squaring it, the negative doesn't matter. So 0.248 squared times half of 49, you get 1.507 joules. So the potential energy at this point is 1.507 joules. What is the kinetic energy? Half mv squared. So the mass was a half a kilogram. What's the velocity? 1.668. 1.668 squared. So 0.5, which is half, times another 0.5, times 1.668 squared. It's equal to 0.696 joules. Okay, so we have 1.507 joules, 0.696 joules. Now let's calculate the maximum velocity and maximum acceleration of this system. Okay, the maximum velocity is what? Well, the maximum velocity, like I said, is reached at the equilibrium point. It's going the fastest. What is the maximum velocity equal to? This part, whatever is in front of the cosine. 0.3 times 9.899. So 0.3 times 9.899, that gives you 2.9697 meters per second. Okay? So that means in the middle, if it's going to the left, it's going to have negative of that velocity. And if it's moving to the right, it's going to have positive of that velocity. That's the fastest, right? What is the greatest acceleration? Maximum acceleration? That's going to be whatever is in front of the sign here. 0.3 times 9.899 squared, right? 0.3 times 9.899 squared. 29.397. 29.397 meters per second squared. When is the maximum acceleration going to occur? Well, if you're on the most compressed, maximum acceleration positive 29.397. If you're most stretched position, it's going to be negative 29.397. So over here, the most maximum acceleration, this way, when you're over here, your acceleration is to the left because you're about the verge of experiencing a large force this way, which is going to make you go back, right? So you have 29.397 meters per second squared to the left over here. Now another thing we could do is to add their energy, add this potential energy and add that kinetic energy, and see if this makes sense. The total energy, 1.507 plus 0.696, 2.203, right? Joules. 2.203 joules. Does that make sense? Well, since we know the maximum velocity is 2.9697, what's going to be the kinetic energy when it's in the middle? Okay? The kinetic energy in the middle is gonna equal 1/2 times its mass times this velocity squared, right? So let's see what that comes out. It comes out to be 2.205 joules. Okay? That's probably like rounding error. If we are a little bit more exact with the numbers, we could probably see we did a little bit of rounding here. So most likely the answer here is 2.205. So a little bit rounding here and here. So what did we just show? The sum of the kinetic energy here plus the potential energy here should equal to its kinetic energy here, because in the middle it has no potential energy, right? So the total energy in here equals total kinetic energy in the center. The other thing we can check is what is its potential energy here or here, right? What is its potential energy at the two ends? Potential energy maximum is 1/2 k x max squared. Actually, this is one of the first things we could have answered, because k we already know, 49, x max is 0.3. So this one has the least rounding in it. That's 24.5 times 0.09, 2.205. 2.205 joules. So now I know which one has the least rounding. 2.205 joule, 2.205 joule potential energy. In the center, it has 2.205 kinetic energy, and then the sum of the kinetic and the potential here also equals 2.205. So now I know a full analysis of this problem. So now you know how to approach these. Okay, thank you.